Now let's take a look at of all the sorting algorithm that we have covered in this topic. So we covered quicksort and merge sort. So before this topic, in topic 5, we covered bubble sort, insertion sort, and selection sort, which are all quadratic algorithms. So quicksort have average time complexity n log n, but the worst case is n square. So that's the main weakness of quicksort. Quicksort is very fast in practice. Well, so that's maybe that's where the name quicksort come from, and it doesn't require an auxiliary array. So the space overhead is a recursive function call, which there is a way to make sure that at most log n even when the worst case happens. So essentially, this is you don't do recursive call on the two sub. You don't do recursive call on the two parts. So you do recursive call on one of them, and then for the other one, you actually don't need recursion. You just reset your variable. So just like in merge sort, we instead of doing recursion, we can do iteration. So you can use idea somewhat similar to that to avoid doing recursion both. So then you can always use recursive call on the subarray that is smaller. So then the bigger part, which if you use recursive call, will result in more depth in recursion. That can be done by iteration. So yeah, so that's a quicksort. Main weakness is a worst case quadratic. Merge sort have a worst case n log n. So that's if we don't care about constant, that's as fast as we can get. In terms of constant, it's slightly slower than quicksort, but it's still reasonably fast. But the main weakness of merge sort is it requires auxiliary array, so that is a linear space complexity. So if you take a data structure and algorithm or algorithm courses later, you will most likely learn heap sort, which the benefit of heap sort is it does not require a linear amount of actual space. So it's also recursive algorithm, so it's only log n actual space for sorting for space, and the time is worst case in log n. So this is very helpful when you are writing code for devices where time guarantee is important. So you don't need to be extremely fast, but you want to make sure that there's no input that will make you very, very slow. So this may be the case in embedded system. So writing software for some small hardware, there's some special, I don't know, for let's say for spaceship, then you may want to make sure that there's no, even in the worst case, it doesn't take too long. So in that case, maybe you want to use heap sort. But in general, it's slower than quicksort, even though they have the same complexity. So the constant is larger in heap sort most of the time. And there are many other sorting algorithms, but there's really no need to know unless for you have a very you're specializing in this area. There's really to know more than the 3 elementary algorithm and these 3 quicksort, merge sort, and heap sort for comparison sort. So also there's the counting sort, which is the simple idea, but can be very efficient if the domain size is small, and there are a few extensions based on that. So I think those will be enough for most, I guess at least for a computer science bachelor's degree.